Welcome to our talk. What happens when service mesh maintainers get a taste of their own mesh? In this talk, we're going to tell you about our journey from being service mesh maintainers to becoming end users of the mesh we used to work on. I'm Risha. I'm a software engineer at Buoyant and Linkerd maintainer.
Hi, I'm Carol. I'm also a Linkerd maintainer and a Buoyant software engineer, currently working on Dive.
So today you'll hear about our experiences working with Linkerd, what it was like becoming an in-house prod Linkerd user, and some bugs and adventures we had along the way. For most of my time at Buoyant, we've been focused on building Linkerd, and we have a suite of integration and unit tests, which my coworker Siggy has a KubeCon talk about, which you should check out. It's about how Linkerd leveled up its CI. And besides our awesome CI, we rely on users for good bug reports. But we've never been on call for a Linkerd installation ourselves. Until Dive, we're building a SaaS app, and now we get to experience the joys of running Linkerd and also the bugs. We got to practice what we preach in terms of interacting with open source maintainers and filing good bug reports, and we got a good dose of user empathy. Before we dive in, I want to tell you a little bit about Linkerd and Dive. Linkerd is a lightweight service mesh. It consists of two parts, a data plane and a control plane. The data plane consists of lightweight proxies that run alongside our application. And the control plane consists of a set of services that manage collecting and displaying metrics, proxy configuration, service discovery, and other things. Dive is the SaaS product we've been building. It's a developer UI for your Kubernetes platform. On it, you can do things like set service runbooks, manage service owners, configure SLOs, and watch rollouts. During this talk, we'll tell you a little bit about how Linkerd helped us run Dive, about how we as Dive builders and Linkerd users helped the development of Linkerd, and about how open source maintainers and users can work together to benefit both. Now Carol's going to talk to us about how Linkerd helps run Dive.
Thanks, Risha. As Risha said, we went from not running any services ourselves to suddenly having to operate this application. But of course, we know a little bit about running Kubernetes apps in production. Now was the time to practice what we preach, and one of those things is running a service mesh. This is exactly what we recommend to other people, not just because we happen to make Linkerd, but because we think it'll make our lives easier. This is the Linkerd web dashboard, and as you can see, Linkerd offers golden metrics, so success rate, request volume, latency, for every service without you having to set them up yourself. Our services at Dive are gRPC, so we wanted to take advantage of gRPC load balancing, and we wanted automatic TLS between our services. There's a few more things that we wanted, and you'll hear about those later in this talk. So our first step as Linkerd end users was fast and simple. We already had the CLI installed. So using the CLI, we installed the control plane into our production cluster, and we meshed our services by adding the data plane proxies. One of the first ways that Linkerd helped Dive was to debug high latency issues. We'd been seeing alerts for P95 latency above 50 milliseconds in our prod cluster, which was concerning. But we had configured Linkerd specifically to provide per route metrics for exactly this reason. So we were planning on using the Linkerd routes command to investigate the cause of that latency. But there were no metrics. When we tried to get metrics using the Linkerd routes command, Linkerd did not return route metrics. And looking into why, we saw that the header used by Linkerd to attach metrics to routes was missing. And some of our team members had a suspicion that it was Nginx that was interfering with that header setting. So we teamed up with some people on the Linkerd maintainer team, and the suspicion was confirmed. We had not configured Nginx correctly. Once we set the Nginx config gRPC set header with the override header, we were able to see that success rate and latency data for the routes we wanted to inspect. So great, problem solved. If we want to be good open source citizens, we wanted to make sure that if we made the mistake, we would update the docs so others didn't have to. But oops, it was already in the docs. We just hadn't read the configuration instructions correctly. So thanks Linkerd for the great docs and helping us investigate our high latency. But we wanted to use Linkerd to inspect another kind of slowness. We used GraphQL heavily in Dive development, and some of our queries were really slow. We were using the Linkerd tap command to investigate slow requests. If you haven't used tap, it allows you to listen to a traffic stream for a resource and see the real-time request data. GraphQL requests are sent via post requests, with the body of the request containing the query. If we could run Linkerd tap and see those post request payloads in the terminal, it would really help us analyze why and where the slowdown was happening. So we contacted Linkerd maintainers and asked them for support of tap bodies. But it turned out that tap bodies were not the solution to the problem, at least not immediately. Alex, one of the friendly Linkerd maintainers, said that tap bodies are on the Linkerd roadmap, but in the meantime, we could already use something that's supported by Linkerd, which is distributed tracing. Once we installed distributed tracing, it helped us dig into our requests in detail. So setting up Linkerd helped Dive a ton, both in all of the conventional ways that a service mesh helps your application and in the expertise shared by the Linkerd maintainers. We also got a reminder of the value of reading the full manual. But Dive has also helped hold up our part of the bargain too. And now Risha is going to talk about how Dive's heavy use of Linkerd has improved the mesh itself. So take it away, Risha.
Thanks, Carol. In this next section, I'm going to talk about how we as end users help the development of Linkerd. We live life on the edge. We use Linkerd's weekly edge releases and we upgrade every week. This means that we discover bugs first. Also that we get nice new features first. Some of the bugs we find are specific from upgrading from one Linkerd version to another, but others are generally applicable. Before I talk about some of the bugs we found, I want to mention a tool that we use all the time, which is Linkerd check. It's really handy, and what it does is it goes through each component of Linkerd and makes sure it's running as expected. You get a really nice summary output, and this is really useful for when you install Linkerd, before you install Linkerd to check your cluster, and when you're upgrading to make sure before and after your Linkerd installation is working. As I mentioned, we upgrade to the latest Linkerd Edge weekly. How do we do that? We run Linkerd upgrade to upgrade the control plane, and then we upgrade the data plane by restarting each pod to pick up the latest version of the proxy. We use Linkerd check in here because Linkerd check outputs the first out-of-date proxy it encounters. What this actually was a little tedious because the workflow was to restart a pod, run Linkerd check -- proxy, get the next pod that was out of date, restart that pod, and repeat. What we thought was, wouldn't it be nice if Linkerd could just output all of the pods that were out of date so we don't have to keep running in this tedious cycle? So we talked to the Linkerd team, and we got our fix. Linkerd check -- proxy now outputs a list of pods with out-of-date agents. So you can just see all of that in one, and we don't have this tedious upgrade cycle that we used to. Linkerd version also now outputs a summary of the number of pods that are of each proxy version. So this wasn't a bug, but it was just part of our workflow, and us talking to the Linkerd team about the workflow caused us to get a fix that helped us a lot. And it wasn't very hard for the Linkerd team either, so this kind of benefited us with very little effort from everyone. The next thing I want to talk about is an issue we ran into when upgrading from one edge to another. So as part of our weekly upgrades, we try to do Linkerd upgrade and we get some kind of render error. We file a bug, we immediately get a workaround so that we can upgrade, and we get a fix that also includes an integration test that would have caught this in the first place. So what I want to say here is that when we as users file bug reports and they get fixed and they get tests, it means that improves the lives of everyone and not just us. The last thing I want to talk about is the fact that all the different users have different cluster configurations, and these different configurations or cluster states can trigger different bugs, and that's super helpful for just testing Linkerd on a wide variety of configurations. For us, this manifested one day when we were running Linkerd check and it was hanging. We knew that because we had configured our pods kind of incorrectly, that they were being evicted at large rates, and we realized that Linkerd check was hanging on these evicted pods. So we found a bug. And the Linkerd team fixed this by not classifying evicted pods as failed. Again, this is a common case that other people would have encountered, and the fix benefits everyone. It's not just us out there filing these bugs. We have a lot of edge users and great bug reports coming in. And this is just helping everyone and helping Linkerd be a better project. Next, Carol is going to talk about how end users and maintainers have a symbiotic relationship and how they can help each other.
We've shared some stories about how a service mesh has helped Dive and how our heavy use of Linkerd has helped Linkerd improve. But there's one more set of benefits that has come from working side by side. It's not common that you're able to be in the same room or on the same screen share in this Zoom day and age with someone who is using your tool in production or building the technology you're relying on. And this ability has really made a difference in both projects. Service owners today evaluate their services with SLOs, service level objectives. And one of Dive's key features is adding SLOs to your service. What you do is you specify your SLO and time frame, and Dive computes your error budget and compliance based on the metrics we get from Linkerd. So of course, we want to dog food our own services, so we set up SLOs to be automatically added for Dive components. But when we added SLOs to the Dive agent, it highlighted to us that our agent was always out of SLO. How could this be? The only thing this component does is to get scraped by Prometheus, so this should be at 100%. So we filed a bug report in the Linkerd repo. Our coworker Siggy filed this ticket. You can see there's a great summary, there's reproduction steps, and below this was detailed logs for the failing Prometheus scrape. The Linkerd maintainers dug into the issue, and they found that first, the error messages in the logs weren't very helpful. So Alex filed a ticket for better error messages, and as a result, we have a better Linkerd debug tooling for this entire class of failures. So that was already a win for Linkerd users. And it also took us a little further to solving the issue for Dive, and we solved it. This one was very unusual in that it manifested not as a bug in Linkerd, but in a misconfiguration that the Dive agent pulled in from some Linkerd code it was using as a library. Ultimately, Alex discovered that the admin server that we were using, which again we had imported from Linkerd's code, was closing connections with a timeout interval that was the same as the interval configured for liveness checks, which created a race condition. The fix was removing that timeout interval. So our dog fooding led to bug fixes in Linkerd, and it also improved debug tooling in Linkerd to help with future investigations for many other users. And as you can see, it got Dive's own SLOs nice and healthy. Look at that beautiful green 100% we have now, thanks to Linkerd. This cooperative debugging to fix our failing SLOs mostly took place asynchronously over a period of days and GitHub issues, but we've also been able to take advantage of real-time debugging. While debugging an issue with Linkerd proxy data, the Dive team needed to share information with Linkerd maintainers, so we spun up a separate cluster for Dive staging. Once the Linkerd maintainers were able to have access to our cluster, they were able to diagnose an issue they'd been hearing about from other users but couldn't replicate. Not only did this isolated environment help Linkerd, it also benefited the Dive team because we moved to having two separate staging and production clusters. And keeping those separate has been invaluable as we support more and more Dive users and need to do more testing before pushing things to production. There was another instance of debugging a different issue where a Dive engineer actually ran Wireshark and paired with a proxy maintainer. Not only did this help figure out the Dive issue, having direct access to someone's production data gave more insight to the Linkerd team about how Linkerd is used in production.
In this talk, you've heard about how building Dive has helped us become better Linkerd users, about how Linkerd has helped Dive be more reliable and easy to operate, and about our various adventures along the way. Throughout this, it's been clear that good communication is key, whether that's filing a bug report or telling us about your workflow so that you can get feedback. When someone files a bug that helps us fix a bug in Linkerd, everyone benefits. So we've tasted the mesh, and we can confirm that it is delicious. There's a whole bunch of helpful and friendly people on Slack. You can join us at slack.linkerd.io. And if you'd like to learn more about Linkerd and Dive, I've thrown up some links here. The slides for this talk will be available at bit.ly/tastethemesh. Thanks for coming to our talk.